morning class. I, R.K.Kanojia, is going to teach you Computer Science, Chapter Boolean Algebra, Part 2. Before start lecture, just quick review of previous lecture. Preposition. As you know, preposition is a statement that result comes in either true or false, and it is of two types. One is simple, which consists of single statement, and compound, which consists of two or more statement. Then operator that joins two or more preposition. There are different types of operator. First is disjunctive. In disjunctive, an OR operator is also known as OR operator and represent by the symbol plus or V. And the table of this, A and B are two preposition having value 0, 0, 0, 1, 1, 0 and 1, 1. And in OR operator, A plus B, when any one is 1, result is 1. When both are 0, then result is 0. So here it is disjunctive. Next is conjunctive. Conjunctive means and it represents by the symbol dot or the symbol, and to table A and B for the same value A and B. A dot A and B, when both are 1, then result only 1. So result would be 0, 0, 0, 0, 1 is 0, 1, 0 is 0 and 1, 1 is 1. Then next is negation. In negation, it's just opposite of a column. Like A is a column, A bar or A dash will be 1, 1, 0, 0. Then a conditional. It is also known as implication and represented by the symbol single side arrow, and when A and B, A implements B. In implements 1 to 0 is 0, rest will be 1. And then last operator, biconditional. It is also known as equivalence and represented by the symbol double side arrow. And in A equivalence B, for the value A equivalence B, it would be when same number like 0, 0, it would be 1. When it is opposite 0, 1 or 1, 0, it would be 0 in this case. And when it is same number 1, 1, output would be 1. Now comes to new topic, properties of 0 and 1. X is a preposition. As you know, X is a preposition. Its value is either 0 or 1. When X plus 0, X plus 0, it is 0 plus 0. And when it is 1, it is 1 plus 0. And what you know, 0 plus 0 is 0. And 1 plus 0 is 1. So what is the result? It is same. So you can say X plus 0 is what? X. Same. X dot 0. No. X dot 0. When it is 0, it is 0 dot 0. And when it is 1, 1 dot 0. And 0 dot 0 result is 0. And 1 dot 0 result is 0. So you can say in any situation, any value, 0 dot anything always be 0. Third is x plus 1. X plus 1. When x is 0, it is 0 plus 1. And when x is 1, it is 1 plus 1. 0 plus 1 is 1 and 1 plus 1, it is 1. So in any situation, 1 plus anything always be 1. Then x dot 1, when x dot 1. X is 0, it is 0 dot 1. And when x is 1, it is 1 dot 1. 0 dot 1 is 0 and 1 dot 1 is 1. So it is same as x. What it is 0 1, output is also 0 1. So you can say x dot 1 is x. Then Boolean laws. First is idempotence law. Says x plus x is equal to x, and second is x dot x is equal to x. How it is? Just check. X is a preposition, value 0 1. When you say x plus x, so it means 0 plus 0. And when it is 1, 1 plus 1. What is the value of 0 plus 0? It is 0. And 1 plus 1 is 1. So you can see it is same as x. So x plus x is also x. And second, x dot x. X dot x. When x is 0, it is 0 dot 0. When x is 1, it is 1 dot 1. 0 dot 0 is 0 and 1 dot 1 is 1. So same as x. Then involution, x double bar is x. X is 0 1. When x complement, x dash, it is 1 0 opposite of x. Again further take another complement, x. So again opposite of this x complement column, so it now becomes 0 and 1. So it is same as x. So x double complement is x. Now third is complementarity law. Complementarity, x 0 1, x bar opposite of 1 0. Now x plus x bar. So it is a plus operator between first two columns. 0 plus 1 is 1. And 1 plus 0, it is also 1. So you can say x plus x bar is always be 1. And what about x dot x bar? X dot x bar. It is a dot AND operator. 0 dot 1 is 0 and 1 dot 0 is 0. So you can say x dot x bar is 0. And two more. One is commutative. Commutative, x plus y is y plus x, and x dot y is y dot x. Then absorption law. Here it's x plus x dot y. X dot y is equal to x. How it is? Let's take a LHS part. LHS is x plus x dot y. As per property of 1, x can be written as x dot 1. And now we can take a common x. X is a common, so in bracket it is 1 plus y. And 1 plus y, property of 1, it is 1. So x dot 1, because 1 plus y is equal to 1, property of 1. And x dot 1 is equal to x. So it is R. Then distributive law. X plus y dot z is equal to x plus y dot x plus z. And second, x dot y plus z is equal to x dot y plus x dot z. Then associative law. X plus in bracket y plus z is equal to x plus y in bracket plus z. And then x dot y dot z is equal to x dot y dot z. Then very important, De Morgan's theorem. X plus y whole bar is equal to x bar dot y bar. And x dot y whole bar is, here it is an example how you use laws for simplification. X dot y in bracket x dot y plus y dot z. Here x dot y multiply in bracket, so it is xy dot x dot xy plus xy dot y dot z. Then as you know, x dot y xy treat as x, and same x dot x is x as per law. And then here it is a xy is common, so it xy in bracket 1 plus z, and 1 plus z is equal to 1, property of 1. So finally it is x dot y. Next example, simplify the following equation. Next step, put the De Morgan's theorem here at a dot c whole bar. A dot c whole bar becomes a bar plus c bar, De Morgan's theorem. Then take a bar common in between two terms. A bar is common, is in bracket it is bc bar plus 1. And as you know, bc bar plus 1 is 1. So this term become 1. So rest is a bar, and c bar plus bc. Then apply distributive law. In distributive, x dot y z is what? X plus y and x plus z. So x plus y dot z is x plus y dot x plus z. Then after a plus a bar, it becomes 1. So rest it is here, and here c plus c bar becomes 1. So this term is here. Then b bar plus b is 1. So it is 1. So a bar plus c bar plus 1. And as you know, 1 plus anything always be 1. It is a property of 1. So final answer is 1 here. Then how you find out the complement of an equation? Equation is given f is equal to a plus b plus c dot d bar plus e. So first find f bar. F bar is whole complement of the equation. Then as per De Morgan's theorem, x plus y whole bar is x bar dot y bar. So it is x and rest is y. So it is x bar means a bar dot y bar. Rest whole bar is y bar. Then further break here, it is x and it is y. So it is x dot y whole bar. And as per De Morgan's theorem, x dot y whole bar is x bar plus y bar. So it is x bar plus y bar. And then further break here, it is x b plus c whole bar is b bar plus b bar dot c bar and d bar plus e. Now it is d double bar dot e bar, and as you know, d double bar is d. So it is a bar dot in bracket b bar dot c bar plus d dot e bar. Now a multiply in bracket, here it is a bar dot b bar dot c bar plus a bar dot d dot e bar. Then principle of duality. This is a very important principle used in Boolean algebra. This states that starting with a Boolean relation, another Boolean relation can be derived. Means equation is given, you can derive the new equation. How it is? First, just change all or sign with dot sign. Change each dot sign with plus sign. And 0 replaced by 1 and 1 replaced by 0. The derived relation using duality principle is called dual form of original expression. The new Boolean equation will also be a valid Boolean equation. So if first equation is valid, so after deriving a new equation, it will be also a valid equation. For example, a plus a bar dot b is equal to a plus b. As you know, it is a valid equation, and when you find a dual form, in dual form, plus convert in dot and dot convert in plus. So here it is dual form, and dual form is also a valid equation. When you multiply a in bracket, so it is what? A dot a bar plus a dot b, and as you know, this one is 0, so it is 0 plus a dot b, and it is also a dot b, so it is RHS. So it is also a valid equation. When first is valid, so after finding dual, it is also a valid equation. It is an example of principle of duality. If show that the dual of this equation is equal to the complement of second equation. First find of dual of first. As per rule, dual all dot sign here, dot sign, so it convert in plus. So every dot sign convert in plus and every plus convert in dot. So it is a dual form. Now complement of second equation. Complement of second equation. First put whole bar here. Put a whole bar. Then next step, q multiply in bracket. So when q multiply in bracket, it is first as it is p bar q r bar plus p q r bar and then whole bar. Now whole bar is bracket as per De Morgan's theorem. It is x plus y plus z whole bar, so it becomes x bar dot y bar dot z bar. Now bar further bracket, it is p bar plus q bar. Now it has become double bar and r bar plus p double bar plus q bar plus r double bar dot p bar plus q bar plus r double bar. Now double bar will remove, so finally it is complement. As you can see, the dual form, it is same as complement, hence proved. So it is equal to its complement. Different terms. The preposition that have some combination of 1 and 0 in the truth table column are called contingency. A column which contains some are 0, some are 1, it is called contingency. The preposition that having nothing but 1 in the truth table column are called tautologies. So a column which contain all value is 1, it is called tautologies. The preposition having nothing but 0 in the truth table column are called contradictions. So column which contain only 0, it is called contradiction. Then a consistent. Two statements are consistent if and only if their conjunction is not a contradiction. When two column put a conjunction means and if all value is not 0, then it is consistent. You can see the table here, two column A and B. So it is a contingency because some are 1, some are 0. In contingency, you can see some are 1 and some are 0. In tautology, A plus A bar, all column value is 1. When all column value is 1, so you can say it is tautology. Here A dot A bar, in A dot A bar, all column value is 0 here. When all column value is 0, it is contradiction. Consistent when two column dot is all are not contradiction. When it is not a contradiction means all are not 0, so it is called consistent. Here you can see that this column is value 1. So if all are not 0, then it is consistent. Then a converse. The converse of a conditional proposition is determined by interchanging the antecedent and consequent of the given conditional. For example, P is a statement, it is raining, and Q is a statement, sky is not clear. Then P implement Q. It is an implement operator. Then statement is what? If it is raining, P because it is raining. If it is raining, then sky is not clear. So it is P implement Q. So it converse form just interchange antecedent to consequent. Now it's Q implement P, and statement would change. Now it becomes if sky is not clear, then it is raining. So in converse, just interchange antecedent and consequent. Then inverse. The inverse of a conditional preposition is another conditional having negated antecedent and consequent. For example, in saying just put negated in both antecedent and consequent. So if we implement Q, if it is raining, then sky is not clear. So opposite, put a not sign in both statements. So it inverse form would be P not implements Q not, and statement is if it is not raining. Before it is raining, not raining. Then before it's not, sky is not clear. Then now it is sky is clear. Put negation in both antecedent and consequent. Next is contrapositive. The contrapositive of a conditional proposition is formed by creating another conditional that takes its antecedent as negated consequent. Antecedent now it becomes negated consequent, and consequent becomes negated antecedent. Here, same statement, P implements Q. Now Q not, because consequent it becomes negated antecedent, and antecedent now it becomes negated consequent. So its contrapositive is what? Q naught implements P naught. If sky is clear, then it is not raining. Student, please note down this exercise. This is another exercise related to complement. Use De Morgan's theorem here. Then another exercise of simplification. Use laws and write laws also. Thank you, class. Have a great day.